Hello everyone, so this is our short module on electrostatics and we have some subtopics. We have charge, we have Coulomb's law, and we have electric field intensity. First part will be charge. So what is a charge or an electric charge? It is the basic property of electrons. We know that in the atomic structure, the electrons are the one outside the orbital, and of course there are protons and other subatomic particles. Electrons are negatively charged, while protons are your positively charged subatomic particles. And we know from our previous lessons that when they have the same charge, they tend to push each other away, which means that they repel each other. And when they are opposites, or if one is positive and one is negative, they would be attracting each other. So this is what you call the law of charge. Your electric charge is actually the basis of electricity. The charge of an atom is determined by the subatomic particles that make it up. So in this atom, of course, in the middle part will be the nucleus, and inside the nucleus will be your neutrons and your protons, while outside, which we call the orbital, will be where you would be locating the electrons. And the proton has a positive charge and is always located in the nucleus. The neutron has no charge, which means it's neutral, and it also is located in the nucleus as it fills in the spaces between the protons, while your electron, like what we previously mentioned, it has a negative charge and is located outside of the nucleus in an electron cloud around the atom, or what we call the orbital. So because atoms have the same amount of protons and electrons, they tend to be electrically neutral. For example, nitrogen has an atomic number of 7, which means 7 protons orbits by 7 electrons. Electrons and protons have the same magnitude of charge, and we know that the elementary charge, or the quantity or the value of charge, is for an electron, that's negative 1.6 times 10 to the negative 19 coulomb. For the proton, since it's positively charged, then its value is positive 1.6 times 10 to the negative 19 coulomb. That is why electrons are forced to orbit around the nucleus. And it is electrostatic force that holds the atoms together. And again, you go back to the previous slide. In the law of charges, like charges repel and unlike charges attract, meaning if it's positive, that would repel, or they would bounce off each other. If it's positive, negative, they have the tendency to attract. When it comes to sizes, the proton and neutron have about the same size or same mass, which is around 1.67 times 10 to the negative 27 kilogram, while an electron, since it's outside and it floats freely in the electron cloud, it actually has a much smaller mass, which is 9.11 times 10 to the negative 31 kilograms. So if you want to put it into perspective, on the figure on your right would be the comparison of the size of the electron versus the size of your proton. But then again, this is just for comparison of sizes. This is not not intended to be exact, but we know from this figure that the electron is typically really smaller than your proton. So there's a question here: how do atoms become charged? So atoms become charged when they become more positive or more negative, removing or adding a proton or an electron. So protons and neutrons are bound together by the strong nuclear force, and it is very hard to separate them. Electrons, as we know, can be more easily removed. And because of that, we have to consider that charge is a fundamental quantity like mass. It is usually denoted by Q. It has a fundamental unit of a coulomb. So when it's charged, our unit is the coulomb from its inventor, or should I say the scientist that conceptualized charge. That will be Charles Augustin de Coulomb. So what is a 1 coulomb? An object would have 6.25 times 10 to the 18 extra electrons to amount to 1 coulomb of charge. Therefore, 1 coulomb is equal to 6.25 times 10 to the 18 electrons. A lightning bolt is estimated to carry a charge of 10 coulombs. And of course, charges can only be in multiples of E. Always remember that a negative E, which is an electron, has 1.6 or negative 1.6 times 10 to the negative 19 coulomb, while a proton is positive. And let's say, for example, an object that has a net charge of 8 times 10 to the negative 19 coulomb has a net charge of what multiple of E? So we know, we just divide that by 1.6, so 8 divided by 1.6, that is around 5 electrons, which means 5 electrons were removed. So if we're doing it in multiples, 1 electron is around 1.6, 2 electrons 3.2, up to the time that you get to what is required in the short problem. If it's 5 electrons, then we have 8 times 10 to the negative 19 coulomb. And a while ago, it was also mentioned what electrostatic force is. In detail, this is a non-contact force, meaning they don't have to touch each other, like the gravitational force, except instead of two masses exerting force on each other, the two objects or charges exert a force of repulsion or attraction. Any charged object can exert the electrostatic force upon other objects, both charged and uncharged objects. Hopefully that would be our short introduction on charge. And there's a formula that is very important when you talk about electrostatics, and that will be Coulomb's law. So Coulomb's law quantifies the magnitude of the electrostatic force. So what we're getting when we're using Coulomb's law, F is a force, so it's in newtons. So Coulomb's law gives the force in newtons between charges Q1 and Q2, where R12 is actually the distance in meters between the charges, and K, the constant, is 9 times 10 to the 9 Newton meter squared per coulomb squared. It is simplified. You can only use Coulomb's law 2 charges at a time. So if you have 3 charges, for example, then you can either use vector analysis, but still you would have to compute for your vectors 2 at a time. And in formula, F12, meaning the forces between charge 1 Q1 and charge 2 Q2, will be equal to K Q1 Q2 all over R12 squared. You always remember, in the denominator, that will be the distance squared. And to get when it comes to units, F12 is usually, or F is usually in newtons. Your Q should be in coulombs, and the distance between the two charges should be in meters. Remember that force is a vector quantity, so your starting equation gives the magnitude of the force, and you can always use your diagram for the problem to figure out the direction. If the charges are opposite in sign, the force is attractive. If the charges are the same in sign, therefore that force will be repulsive. Coulomb's law is valid for point charges. If the charged objects are spherical and the charges uniformly distributed, R12 is the distance between the centers of the sphere. So just want to illustrate that you always take into consideration the centers of the spheres or the charges, and you have to get the distance between the two centers, and that will be R12. Coulomb's law describes the force between 2-point charges Q1 and Q2. Always remember that force is a vector directed along the connecting line. And again, that's the formula. KQ1 Q2 all over R12 squared, or in basic, that's KQ1 Q2 all over R squared. So just remember that R will always be the distance between the two charges. And K, again, that will be 9 times 10 to the 9 Newton meter squared per coulomb squared. Or there's another formula that you can use using the permittivity constant, EO. This EO here is the permittivity constant, that's 8.85 times 10 to the negative 12 coulomb squared over Newton meter squared. You can use that, but it's simpler when you use 9 times 10 to the 9 Newton meter squared per coulomb squared. Now we go to electric field, the last part. There will be a separate module, by the way, for problem solving. This will just be introducing the concepts, and for problems, I'll be providing another set of another presentation just to cover some problems related to these topics. For electric field, so what is an electric field? A charged particle creates a field in all space. Other charged particles sense the field and experience a force in response. And this distinguishes source charges and test charges. And it's an example, your electric field actually radiates outward. A charged particle modifies the properties of the space around it. So it's a field, meaning it affects, it is where your charges actually interact, your source charges and your test charges. Excuse me. So for example, you have different forces acting. So there you go. So remember that like charges repel and unlike charges attract. The electric field is where these play. So you can actually distinguish what your source charges are and your test charges are. Of course, there could be one or more source charges, and if you need to identify the electric field, E, via force they exert on a test charge QO. So E is actually the force all over the charge. And in the simplest formula, that will be F is equal to QE, where E is your electric field. Again, electric field is just a ratio of the force versus the charge. So that's F over Q. The units of electric fields, because of that formula, will be Newton per coulomb. And later on, you will learn that the units of electric field can also be expressed as volts per meter. So what is an electric field? The electric field can exist independent of whether there is a charged particle around to feel it. And always remember that the electric field direction is the direction of a positive charge would feel a force. A positive charge will be repelled by another positive charge, and therefore the direction of the field is away from the positive and towards the negative. So it's always like that. So it opposes the positive charge, or the QO, outward. So it is going away from the positive and always going toward the negative, as seen from the figure. So from Coulomb's law, let's combine the two concepts. So Coulomb's law states that F is equal to KQ1 Q2 over R12 squared. You can treat Q1 as the source charge and Q2 as the test charge. So let's divide that by Q2. The electric field due to a point charge Q1 is therefore KQ1 all over R12 squared. Or generally, you can use another formula, which is equal to KQ all over R squared, where Q here is your source charge. Okay? So these are just basic formulas. And if we define it as a unit vector from the source point to the field point, then the vector equation for the electric field of a point charge becomes this. So E, or the electric field, is equal to K over Q R squared. And then R with the hat is actually just a vector, or it's a unit vector to indicate the position. You may start with either equation for the electric field, this one or the one on the previous slide. But of course, it is simpler. We know that KQ all over R squared, that can also be our E aside from F over Q. Okay. As an example, calculate the magnitude of the electric field at the electron's distance away from the proton in a hydrogen atom, which is 5.3 times 10 to the negative 11 meters. So if we have two charges, so that's kq, so that's 9 times 10 to the 9 for k, and each electron, we're talking about electrons, okay, it's 1.6 times 10 to the negative 19. That will be the charge of the electron all over the distance, which is 5.3 times 10 to the negative 11 squared Newton per coulomb. Okay, that's how simple the electric field is when you compute it. So your answer is 5.1 times 10 to the 11 Newton per coulomb. And as a summary for this module, this is just an introduction to the different concepts. We talked about charges, and we know that charge is a fundamental quantity like mass. It is actually the basis for electricity. We were able to be familiar with the Coulomb's law formula, which is F12 is equal to KQ1Q2 over R12 squared. Or in the easiest sense, that would be KQ1Q2 over R squared. And we talked about electric field, and you were presented with two formulas that you can use for electric field computation. You have F is equal to QE, where E is your electric field, or you can use the E is equal to KQ R hat all over R squared. So that is our first module on electrostatics. You can check your canvas for the activity presented for this topic, but this will be followed up with a module on the different problems that we can encounter using Coulomb's law and electric field. Okay, so if you have questions, just send me a DM and we'll go and I'll be posting the next video. Thank you.